So another one of your projects is printing on Mars, which is
Yeah,
extremely popular right now.
yeah.
So how did you get into that? Was it a competition?
No, we were asked by the TU Delft to join in because first of all, it's a small country. We know each other, and I know some people that were doing a PhD at Delft, and they were doing a Mars project. And I actually was never into printing stuff for Mars because I think it's quite, far away, and it's not very practical. But we were asked to print these designs for them, and we thought, it's nice to be involved with the university. It's a very good university, and it's a nice project also for the European Space Agency. So we became involved. And the great thing about the project is within a few weeks, we had printed their first designs. And one of the things they did on Mars, you have to think in a completely different set of rules, which is really fun. They have heat issues. And so the printing pattern they do is they create a lot of surface area so that you have a lot of heat dissipation, right? The same way you have a car engine or a motor, it has a lot of surface area to dissipate the heat. And I thought that's cool because that's something that's really good to do with the 3D printing, right? In plastics, but also in concrete. And about a week later, a client came to us and said, we have some issues on the railways with our electrical boxes, that there's a lot of heat generated in the summer. Could you 3D print something? And I thought, hey, we had this great example 3 weeks earlier of how to dissipate heat with a pattern. So immediately my thoughts of, Mars it's not very useful to think about it were, negated in
Ah,
that
that's
we
interesting.
immediately had a lesson learned from the project on what we could do practically now here on Earth as well. So that's the fun thing about that project is that it's quite high level, of course, because it's quite far away, but the lessons can be translated pretty quickly back to Earth.
That's
So that was cool.
fascinating. Yeah, because I
Yeah.
was going through the description and it said like we have to think about subterranean
Yeah.
habitats because of radiation and heat.
Mm.
But then the sculptures that you all printed look like they were towers. So I was going to ask you about that.
Why is that? That's also interesting. But again, I could talk an hour about this.
Yeah.
What they actually decided, and I thought it was really smart because I never thought about it. You have the radiation issues and whatnot, and they wanted to build their habitat inside uh, inactive lava tubes. So apparently on Mars, there's very large lava tubes that are empty spaces, cavernous. And if you would insert a robot into one of these caverns, then you could scan the wall and the shapes that the voids that are left, you could print inside the voids. But the way you want to do that is with a special shape that optimizes structurally. And if you look carefully, the shapes on the Mars objects are also Voronoi. Just like the wall we talked about earlier, the shapes for the Mars objects are also Voronoi, which if you Wikipedia, you'll see is an optimization strategy for structural behavior as well. So it's all connected, right? Because quick side note, one of the interesting things about concrete printing is that you're so form free that you can optimize this type of structural behavior. And I'm really into that, not only to make nice things, but to think about the architectural side and what are the actual conceptual advantages, like the bridge we did. But so you see these Voronoi shapes have to be inserted in these voids in the lava tubes. And that's why you have these sort of tower shapes, because they're all going to be different, right? They're not just printed
Ah,
on top of the earth. So it's
so
it's next
what,
level, but it's
yeah.
very interesting.
So what material did they propose printing with on Mars? The
So
local
they propose,
soil?
yes. So they call it regolith, and this is not my area of expertise, but they refer to it as Mars regolith. So we actually ordered a set or a sample of simulated Mars regolith from the USA, which is extremely expensive per kilo. But we actually tried to print that in our machine, which was successful. So the shapes you see are still printed with our concrete. But in the meantime, we've also done actual simulations of the Mars regolith. And again, it's their project. I don't know how
Yeah.
much they've published about it already. So I can't maybe not go into too much detail, but we've actually done simulated Mars material prints as well.
So the last question about this project, just because I'm fascinated
Sure.
with it.
Yeah,
It-
apparently.
So instead of water, do they propose mixing the powder with sulfur or something?
Uh, that That I don't know.
No. Okay.
So that's too much into the detail,
Yeah.
because there's a big discussion inside on the material side, how that,
Yeah.
what the advantages and disadvantages are. And I know it's a whole discussion. So I don't know the details of how they're going to solidify the actual printed material. Yeah, I don't know.
Because there is a company in the States that claiming to print these structures on Mars, and it's like, to me, it just looks like red pigmented concrete. So I don't know how they're simulating conditions on Mars when they're printing those structures, but it sounds like it's an ongoing research and they're still trying to figure this out.